we would see parameterization of a surface. Parameterization is not like that people have not used, but they don't know that it is a parameterization. So, parameterization in calculus, parameterization in 3D, parameterization of surface. So, that we will see. Before that, we will see what is parameterization. Consider that I have a consider that I have a xy plane. I have xy plane. This is x-axis. This is y-axis. This is x-axis and this is y-axis. Now I have a circle like this. X-axis, y-axis, circle like this. What is the equation of a circle? Or circle is centered at the origin. Then what is the equation of the circle? The equation of the circle is x square plus y square equal to a square. If I talk in dependent and independent form, then y is dependent and x is independent. If that is the case, then y equal to a square root of a square minus x square. Y equal to square root of a square minus x square. That is the formula of the circle. Okay, if that is the case, then what is the area of the what is the area of the circle? Area of the circle, if I try to calculate, then area in calculus is nothing but integration. So if I have x square plus y square equal to a square and y equal to square root of a square minus x square, then y is nothing but function over x, fx dx, and limit of x from lower to higher, that gives the area. So if I have a circle centered at the origin, then from the middle x-axis passes. If that is the case, then area upper half area, if I see upper half the kind of, or just if I want to just, okay, we'll proceed on. So now y equal to square root of a square minus x square, square root of a square minus x square. Now the integration would be to calculate the area in fx dx, square root of y dx, or square root of a square minus x square dx. X limit from to higher, lower to higher, then it would give the area of the circle. So square root of a square minus x square dx, square root of a square minus x square dx, what it is? It is difficult to calculate integration of a square minus x square square root dx. There the method of substitution comes into the picture. There are many ways integration can be calculated, and one of them is substitution. One of them is integration by part. Consider x equal to a cos theta, dx equal to a minus sine theta d theta. Now a square minus x square would become a square minus a square cos square theta square root, and then a minus sine theta d theta. Then it will become a and square root of 1 minus cos square theta sine theta. So a and then a square minus sine square theta d theta. So sine square theta integration is theta by 2 minus the sine square theta integration is theta by 2 minus sine 2 theta by 4. Now, if I see lower limit and higher limit, the radius is minus a to a, minus a to a. I have set x equal to a cos theta. So, if the x is minus a, then cos theta is minus 1, that is pi. Theta is pi. If a is a, then it is 1, theta is 0. So pi to 0, pi to 0. So now I have to calculate pi to 0. Theta by 2 minus sine 2 theta by 4. Pi to 0, if I calculate, it will be minus pi by 2. Minus outside, so it becomes pi by 2 a square, that is the area. Now, since we have taken Cartesian coordinate, y is above the x-axis. So pi by 2 a square multiplied by 2 is pi a square. Pi a square. If that is the case, then area of circle is pi a square. This is substitution. X equal to a cos theta is substitution. Now I am enjoying, I solved it. Do you think that something is hidden behind the scene? Knowingly, unknowingly, you used, someone used, knowingly, unknowingly, someone did something. Knowingly, unknowingly, someone did something. What happened behind the scene? A cos theta. A is a constant. Theta is a variable. X, Y, theta. Three things are coming into the picture. Okay. Then it proves that theta here, X is independent. X is variable. Y is dependent upon X. Now X equal to F theta. X equal to function over theta. This is what we did. A cos theta, x equal to a cos theta, then it is nothing but y equal to fx. Y equal to fx. X equal to f g theta. There is another function over theta. Looks like theta is another system. Theta is another system. What about y minus sin x equal to 1? Y minus sin x equal to 1. Y equal to 1 plus sin x. Let's consider sin x equal to t. What is y dx? Integration of y dx. Then nothing but it is 1 plus sin x. 1 plus t. If x equal to sin x, then dx x equal to, sorry, sin x equal to t, then cos x dx, cos x dx equal to dt. So differentiation of t is dt. So cos x dx equal to dt. Okay, so that is the scenario. Now we can do some change here and there. What about replacing them? Okay, I'll take it simple. Y minus 2x equal to 1. That is the equation of a line. Y minus 2x equal to 1. Y equal to 1 plus 2x. Let's consider 2x is t. If 2x is t, then dx equal to dt by 2. Now I have 1 plus t, integration of 1 plus t dt by 2. 1 by 2 I can keep outside, and 1 plus t I can calculate integration. Now limit would change. If I am setting any limit would change as per the 2x equal to t. What we are trying to do here? Again, integration by substitution. Y minus 2x equal to 1. Y equal to 1 plus 2x. Y equal to 1 plus 2x. Okay, if that is the case, if that is, or in the earlier example I had taken y equal to 1 plus sin x equal to t, then 1 plus t, and then 1 plus t dx. Dx change into dt by cos x. Cos x is nothing but square root of 1 minus sin square x. So dt divided by square root of 1 minus sin square x. Sin x is t, 1 minus t square. So now I had taken 1 plus sin x, so 1 plus t. 1 plus t divided by square root of 1 minus t square. 1 minus t square is 1 plus t, 1 minus t. Then that is 1 plus square root of 1 minus t square. So 1 plus t, 1 minus t square root. So it will come as now the 1, okay, square root of 1 plus t divided by 1 minus t dt. Whatever is the integration, you can use integration by part or whatever it is. We are changing the form. Okay, in first case, it was easy. Calculating the area of a circle through substitution, it was easy. Whatever it is. If I want to make my life easy, then I do the substitution. I take x and it is a function over another variable x equal to, so if I go back to the circular, calculating the area of a circle where y equal to square root of a square minus x square, if I took x equal to a cos theta, it becomes drastically simple. It becomes so simple. I believe I should not give in. I'll try again. So what we were doing was that y, I never thought of this example. Y minus sine x equal to 1. Y equal to 1 plus sine x. Sine x equal to 1 plus sine x. Now I have to do integration of 1 plus sine x. Suppose that I am converting sine x, I am taking sine x as t, then cos x dx equal to t, dx equal to dt by square root of 1 minus t square. Now it becomes 1 plus t divided by square root of 1 minus t square dt. That is the integration. 1 by a square root of 1 minus t square plus t by a square root of 1 minus t square dt. This is the integration. 1 by a square root of 1 minus t square. How someone can calculate integration plus t by a square root of 1 minus t square? Again, you can take as, consider t equal to cos theta. T equal to cos theta. Then 1 minus square root of 1 minus t square is sin theta, plus t is cos theta by sin theta. Now t become minus sin theta. So 1 by sin theta gone, then it is integration of minus 1. T, it is easy now. Plus t by square root of 1 minus t square, denominator becomes sin theta, top is sin theta, gone, t is cos theta. So cos theta d theta. Earlier it was theta. So theta is the integration, theta plus cos theta d theta. That is sin theta. So theta plus sin theta is the integration. Now you can change theta to t and t to x back. What we are doing with this kind of example? I believe I can repeat it again. Equation is y minus sin x equal to 1. Y equal to 1 plus sin x. Sin x equal to t. Let's consider method of substitution in integration. If that is the case, then 1 y dx is the integration, then 1 plus sin x dx is the integration. If that is the case, 1 plus sin x is t, then 1 plus t dx change into dt by cos x. That is square root of 1 minus t square. Okay, now integration is 1 by square root of 1 minus t square plus okay, plus t by square root of 1 minus t square dt. So 1, now consider t equal to cos theta. Again, t equal to cos theta. So 1 by square root of 1 minus cos square theta is sin theta. Plus t is cos theta by sin theta. And here minus sin theta d theta. Now first term will become minus 1 d theta, minus 1 theta, plus next term will become minus cos theta d theta. that will be, that integration will become minus sine theta. So d theta minus sine theta, that is the integration. So d theta integration is theta minus sine theta integration is cos theta. Simple. So minus sine, I'm sorry, cos theta d theta. So that is sine theta. Here theta. So theta plus sine theta is the net integration. Now t equal to cos theta I had substituted. Now whatever the t is, that limit I have to change into theta. So theta plus sine theta, theta plus, I believe theta plus sine theta is the net integration. So theta to t, t to x, and that is the net integration. We keep changing the form. Can you see? X equal to a function. If y equal to fx, if y equal to fx, if y equal to fx, then x equal to gt, then t equal to h theta. So function by function, we are unfolding it. This is called parameterization. Parameterization means the x component you are now modifying it to function where it takes a parameter. Parameterization. If I have a circle, and now I'll come back to the circle. Y equal to square root of 1 minus x square, y dx, square root of 1 minus x square dx. Now, this is difficult to solve. Earlier, I went in a fancy way, but this is difficult to solve. Square root of 1 minus x square dx, or x by a square root of 1 minus x square, or 1 by a square root of 1 minus x square. These are difficult to solve in integration. But if you take x equal to cos theta or x equal to a cos theta, it becomes very easy. Dramatically easy it becomes. So parameterization is nothing but, if I set the independent variable, right now we will see more on it, independent variable, that is x, as a function of another independent variable. The actual case is y is function over x. Y is dependent variable, x is independent variable. A square root of 1 minus x square dx, that I have to calculate, where x is minus a to a, to calculate the area of a circle, semicircle. But I don't know the integration. Now can I take x as dependent component and independent component is something else? Then x equal to gt, where gt function, g is a function, g over t. Then this is called parameterization. The independent component, that was x, now you are converting it to dependent component x, and independent component is t. So t is the core independent component on which x is dependent. This is xt plane. New plane that is coming into the picture, that is called xt plane. There is another plane called yx plane. X is independent, y is dependent. Now there is another plane, two planes. One is yx plane, one is xt plane, or xy plane and tx plane. In tx plane, y equal to a square root of 1 minus x square, that is the y equal to. Then x equal to or y equal to square root of a square minus x square, fx equal to square root of a square minus x square. Then here in this plane, x equal to a cos t, a cos t. So tx is another plane, xy is another plane. So now the x, I change it to parameterize. This is called parameterization of a line, of a curve. So parameterization of a curve where independent variable, later we will see more things, the independent variable x, we again brought it as a parametric function, like y is a function over x, x is function over t. Now I can solve it. So now if it is x equal to cos t, then 1 minus x square, a square minus x square. So x equal to a cos t. Then a comes out, it becomes sin t. Sine t and dx become dx becomes minus sine t dt. So now it becomes a minus a sine t dt, a square minus sine square t dt. Sine square t is t by 2 minus sine t2, 2t by 4. Now minus I have kept outside, and now if x equal to sine a sine t, when x is minus a, t is pi, when x is a, then t is 0, x equal to a cos t. Now that is the case, the integration from of the now integration of sine square t is t by 2 minus sine t2 by 4, pi to 0. Then it would become, we saw pi by 2, minus comes into pi by 2, pi a square by 2. So simple now. Otherwise it was different. So parameterization in calculus is nothing but whatever the coordinate system we had, x, y is a coordinate, is a Cartesian coordinate system. What about x and t? What about x and t? Don't know. It's a new coordinate system that looks like that, right? Where t is independent component and x is independent component, and they are related to another way. Okay. So if we make x as a function of another coordinate system, another independent variable, x equal to gt, then g is a function where t is parameter. Parameterization of a line, where the circular line is there. If I am doing parameterization, this is called parameterization. Okay. If it is parameterization, through parameterization I solved the issue, then what is parameter? Can I use this parameterization in more way? Yes, parameterization can be used in vector form. So in calculus, the most basic, in mathematics, the most basic is numerical science. 1, 2, 3, 4. On top of it is algebra. Algebra can be in different coordinate systems like Cartesian coordinate system, polar coordinate system, cylindrical coordinate system, a spherical coordinate system. Now, numerical science, algebraic science in different coordinate systems. From algebraic science, there is one form called vector form. And algebraic science manipulation we can do through calculus. Calculus has nothing to do with the vector. Calculus purely works on algebra. Algebra can be promoted to a vector in a way that vector has components. Each component can be algebraic equation. Each component can be algebraic equation that is based upon algebra. Calculus based upon algebra in a way, calculus does manipulation on algebra. Algebra is based upon the numerical science, where algebra is an equation, parameterized equation, where you can keep changing the variables and keep getting different values. So this is mathematics. So we are talking about parameterization in the sense, if I have algebraic equation x square plus y square equal to a square, then x I replaced with a cos t, a square cos square t equal to y square equal to a square. Then y equal to a square minus a square cos square t square root, y equal to a sin t. Now can you see that y is the dependent component in xy plane can also be represented as the parametric function over t. So x equal to, if y equal to fx and x equal to gt, then y equal to ht. This is parameterized. X, y. In xy plane, we have one independent component x, dependent component y. Now, both are dependent upon another guy, that is t. T falls in now another coordinate system. So now we have Tx plane, x equal to gt, Tx plane, y equal to ht, h is a function, g is a function, Ty plane. Okay, so this is the scenario. Now, if I have a circle, if I have a, if this is x-axis, if this is x-axis, and this is, if this is x-axis, this is y-axis, and it is centered at the origin, then there is a circle. If there is a circle, and if there is any point x comma y, then there is a kind of if there is any point x comma y, then there is a position vector. If there is a position vector, then equation of position vector is xi plus yj. Now we are doing vectorization. Earlier we did parameterization. Now to the curve, that is x square plus y square equal to a square, x equal to a cos t, y equal to a sin t, that is called parameterization. Can you do parameterization of a curve where x square plus y square equal to a square? This is parameterization. X equal to a cos t, y equal to a sin t. Can I say x equal to t, then y equal to a square root of 1 minus t square? Then t is again, yes, that is also a parameterization. Again we land up into tx plane, ty plane, and xy plane. Any we have x equal to t, then y equal to square root of a square minus t square. That is again another parameterization. Now if I have a circle and there is a position vector x comma y or xi plus yj, then this position vector can be turned into a cos ti plus a sin tj. A is the now radius of the circle. Then it is r. If radius of the circle is r, then better I can say r cos. Consider, and now I change t to theta, r cos theta I plus r sin theta j. Okay, it landed up into polar coordinate system. Polar coordinate system is in variation of r theta. So polar coordinate system is a coordinate system of r theta, whereas Cartesian coordinate system is a coordinate system of x and y. So x equal to r cos theta, y equal to r sin theta. We are trying to map two coordinate systems. One is Cartesian coordinate system, one is polar coordinate system. Polar coordinate system is a philosophy of r and theta. XY coordinate system, Cartesian coordinate system is a philosophy of x and y, where the relationship is x equal to r cos theta and y equal to r sin theta. So if I have a vector that is if I have a circle, radius is r, full radius is r, then x equal to xi plus yj is the position vector that can be transformed into r cos theta I plus r sin theta j, r sin theta j. Okay, now let's consider r is constant, because this is a circle. R is constant, r is not variable, only theta is variable. Then I can say this is a vector. So this is called parametric vector. If vector r, vector p equal to xi plus yj, then it is called position vector. But if I change x into kind of r cos theta I plus r sin theta j, now it becomes a parametric vector that is represented by small r. On top of it there is a vector and function of theta. Now, if the vector is r being constant, I am considering r being constant. If r is not constant, then this is a parametric vector r represented as r vector in the bracket. It is a function of r comma theta. If r is constant, then it is a function of theta. So r is a vector and in braces theta equal to r cos theta I plus r sin theta j. If r is constant, then I can take r as one unit circle, then cos theta I plus sin theta j. Now you keep changing theta and then you keep moving along the circle. If you are taking the parametric vector xi plus yj, then it does not make any sense because x is different, y is different. If you keep changing x, then y would not change. So xi plus the square root of 1 minus x square j, xi plus the square root of 1 minus x square j. It can be represented as a parametric vector r vector function over x. Parametric vector is a vector which is a function over some independent variable. It is function over theta, then r vector function over theta. It is function over x, then r vector function over x. If it is function over r and theta, then r vector function over r and theta. This is parametric vector. Since the component of vector are parameterized, now they turned into a function. Earlier it was xi plus yj. Now x turned into t and y turned into a square root of 1 minus t square. X turned into cos t and y turned into sin t. Now they are only function of one independent variable, either t, theta, x, whatever. If that is the case, then it is called parametric vector of a curve, of a line. If it is surface, then it would be dual. So what are the game that we can do through this parameterization? Later we will see Jacobian matrix and those kind of things. Why it is required? You saw, right? The square root of 1 minus x square dx is not possible. There we have to do parameterization. X, now I have to go into xt plane or x theta plane. Another plane comes into the picture. Then how mapping would happen from xy plane to xt plane, or xy plane to x theta plane, or xy plane to r theta plane if it is polar coordinate. So those things, it is very broad area, and this is the most recent research area in a vectorization. We also call it vectorization of algebra. So if I have an algebra, if I go with vectorization, or if I have an algebra, if I go with parameterization, it does too many things. So algebra, then parameterization, and then vectorization. So where vector has each component as a parameterized algebra. So this is the staircase now we are riding. How it solves our problem, that we will see.